In this lecture, I want to take you through an excursion of the Schelde estuary from the past to the present. It has been a very polluted, very heavily degraded ecosystem, and it has been restored to nowadays a quite well functioning ecosystem. And this is based on an integrated approach for the restoration, and that's what I want to discuss with you. So first of all, we will be setting the scene. And the Schelde estuary is situated in the north of Belgium, along the North Sea coast, and is part of Belgium and the Netherlands. Here you can see a map of the catchment of the area, and the overall river catchment of the river Schelde is quite small. It's only some 21,000 square kilometers, and the total length of the river is hardly something more than 350 kilometers. But the estuary is more or less half of the length of the river. It's 160 kilometers, and it starts in Ghent, here where you can see, and it's passing through Antwerp, crossing the Dutch-Belgian border to reach the North Sea in the Netherlands. Very typical for an estuary are two different aspects. First of all, we have the tide which is coming in and which is very important, and secondly the salinity gradient. And in this map you can see very clearly the salinity gradient, and the inset you have the chlorinity in function of the distance, and then you can see that near the mouth it is very saline, like the marine waters. Then gradually it is decreasing and becoming brackish water due to the mixing of the marine and the fresh water. And from this side near Ruppelmonde it is more or less fresh. It is quite strange because you have here a situation where you have typical marine characteristics, the tides, but the water is fresh. And the tides is increasing from the mouth, and the tidal range is increasing up to the zone here in the freshwater tidal area, and it stopped at 160 kilometers from the North Sea, close to Ghent. This slide is giving you just some pictures of the area where you can see the typical marine, the salt marshes at the mouth of the area. A little bit further, the huge estuary with the sandbanks and the main channels, the drowned land of Safting, and then the freshwater marshes much more upstream. And one of the most exciting areas is, of course, the brackish marsh of Safting, which is 3,500 hectares great, and is a typical marsh, as you can see here, with the vegetation and then the creeks coming across the whole marsh. Also here you can see some examples of the different habitats along the Schelde, and this is in the freshwater tidal area, where you can see on the left corner the mudflats, then the tidal marshes, with first the young marshes with the pioneer vegetation, and then the mature marshes, the high marshes. This also is an example of such a freshwater tidal marsh, which is in fact on a European scale a very rare habitat, because most of the freshwater parts of the estuaries has been destroyed either by complete dike building or by the construction of sluices or weirs which were blocking the tides. Also, this is an example of the freshwater tidal marshes, where you see on the left hand still the water at low water, the water line, then the tidal flats, and then the pioneer vegetation, the reed, which is the brownish vegetation, and then the high marsh with the willows, which is the darker brown and green parts in the picture. So to come to a restoration plan of a system like the Schelde, it is very important, first of all, that we understand how it has been developing over time. So in the first part, we will go to the changing geomorphology as a result of a large period of time, decennia, millennia even, of human impact on the system. And here in these maps, you can see on the left how the downstream part of the estuary looked like some 1,000 years ago. And then to the right, you see how it is looking now. And you can see that it's completely different. In the first part, 1,000 years ago, we see that we had large areas with tidal marshes, with some tidal flats, and then a lot of major channels and gullies. To the right, you see how it's looking now with a large channel, and the different colors show when the tidal marshes have been embanked. And you can see that starting from the 13th century onwards, gradually the whole area was embanked, and you can see that more than 150,000 hectares of tidal marsh and tidal flats were embanked over the last more or less 1,000 years. And this change in the geomorphology has a tremendous impact on the hydrodynamics, and that is what you can see in this slide, where you have on the x-axis the length of the estuary from, on the left side, the North Sea near Vlissingen, and to the right 160 kilometers from the sea, the city of Ghent. And you can see for the different time periods going from the year 500 up till now, how the tidal range has been developing. In the beginning, it was only a small tidal range, 2.5 meters, not even reaching Antwerp. And by now you see that it is more than 100 kilometers, more or less, further inland that we have the tides, and also that the tidal amplitude has been increasing tremendous over time. So from maximum 2.5 meters, it is now nearly 6 meters. So a very large increase. And also the place along the estuary with the highest tidal range is now much more further inland than it was in the beginning some 1,000 years ago. And this has very strong consequences. And on the left hand, you see an aerial picture of the present day land. And you can see with the red arrows where you have some dikes. And on the right part of the picture, you see a cross cut through the area where you had the old layers. The brown is the clay which is deposited by the sea, and then the peat and so on. But at a certain moment in 1675, they built a dike. And because of that, of course, what was behind the dike was not flooded anymore. And on the river side of the dike, the tides were continuing to come day by day, and you had the sedimentation, which you can see there. And some 100 years later, they built a new dike, a dike which is higher, because in that 100 years there has been sedimentation. And also, as we have seen in the previous slide, the high water levels have been increasing because the tidal range was increasing. And then you see a new dike built. This, again, at the seaside, you had sedimentation, and on the land side, of course, because there was no flooding, there was no sedimentation anymore. And a few hundred years or a few decennia later, a new dike was built, which is still the present day dike that you can see. And in front of the dike, you have a tidal marsh, and you see on the left still just a little bit of the pelagic phase of the river channel itself. So gradually one have been embanking the whole area, and by embanking the area, you see that you still have sedimentation on the river side and no sedimentation on the landward side. And this has, of course, tremendous consequences. This can also be seen in this cross-section, where you see from the left to the right, from the oldest part to the newest part, and excuse me, you can see that each time on the right side of the dike you have the sedimentation, and by now this level of the polder, which is not flooded anymore, is higher than the older part. So that is exactly the same as in the previous graph, in fact. But the consequence of that is that if you compare the level of the area 1,000 years ago and now, left and right on the picture, then you can see that 1,000 years ago, most of the area was green, and green means that it's the tidal marsh, which is above the high water level in the area. If we see now, then most of it is blue, which means that it is under the high water level, and in fact only the dark brown patch is the drowned land of Saftingen, which is still at the riverside of the dike, and which is still kept keeping sediment, and accretion is happening there. So by embankments, then the whole area did not grow anymore with the sea, but outside of the dike, the water level was increasing, And so the land remains at the same level, but the sea is increasing, which means in fact that you have always getting a more dangerous situation. And the result is, of course, from time to time, some floodings, because if the dikes breach, then the whole low-lying area is flooded, as you can see in one of these pictures from the Middle Ages. But it's not only in the Middle Ages, also in 1953, there was a very severe storm flood, and then very large areas were flooded, and that are the hatched areas on the map on the left. And you can see that it was really disastrous. In the whole Dutch Delta, nearly 2,000 people were killed by these very severe storm floods. And as a reaction of the Dutch towards the storm flood, if you have such a disaster, then of course the governments decide we need to do something, and that was the start of the Delta Plan. And in fact, the idea of the Delta Plan is what you can see on the right in the animation, that bit by bit all of the sea arms in the Dutch Delta area would be dammed. And the idea was, if we dam all of these estuaries, all of these sea arms, then we reduce the coastline only to the line along the North Sea, and these hundreds of kilometers of dikes that we had to maintain along these estuaries are not important anymore, because we have long, large, and one strong and short protection along the coast. And that was in the Netherlands. In Flanders, we had another important storm flood in 1976, and also there some villages were flooded, and then in Flanders it was also decided to take action, and that was in the Netherlands the Delta Plan, and in Flanders we had then the Sigma Plan for the Flemish part of the estuary. And it consisted of several concepts. First of all, we had the higher and stronger dikes, and you can see on the graph from the left to the right what would be the levels of the dike. So in the more outward part, where you have higher storm flood levels, you have higher dikes than more upstream. And the next very important concept is the flood control areas. The flood control areas that you can see here on this picture is in fact a very low-lying area along the estuary. And the idea is that you have near to the estuary a low dike, and away from the estuary a high dike, which you can see to the right. And then during a storm flood, when the water is coming very high, the water can overtop the low dike along the river and fill up the whole of the flood control area, and the area behind the flood control area is protected by the strong and high dike. On the left picture, you can see such a low river dike that is being overtopped during a storm surge. This is exactly the same place during what we call the St. Nicholas storm of the 6th of December in 2013, where you hardly see anymore the overflow dike, because the water is more or less at the same level, and you see that the whole polder area is completely filled. By doing that, there you can store a lot of water, and the water levels more upstream of such a flood control area will not raise that much, because you store all of the water in the flood control area. So the Sigma Plan had three elements: the higher and stronger dikes, the flood control areas, and the finishing part would be the construction of a storm surge barrier very close to Antwerp in Oosterweel. And that would be a construction with three huge pillars. In between you had some gates that could be lowered or taken up, because the shipping is very important in the Schelde estuary, and just closing the estuary was simply impossible, because then you would just stop the shipping. So therefore that construction was devised to allow still the boats to go in and out, but to be able to close it during storms. That was the idea, but already in 2003 it was estimated to cost 1 billion euros, and then finally it was decided not to build it, at least not. So that's one thing. So we have the embankments, which are changing the morphology, because you have a lot of intertidal areas that are lost. But the next element, of course, is that we have the works that are ongoing for the economic development, which is on the one hand the port development, as you can see on the picture in the lower left corner, where you see the large docks that has been excavated and the whole industrial area for Antwerp. But these docks and these industrial areas, they need a lot of ships, and for that the maintenance of the fairway is very important. And in the map you see the red line, which is the fairway from Vlissingen to Antwerp. And because the ships are always going bigger and bigger and bigger and are going deeper and deeper and deeper, the deepening of the fairway is very important. And on the inset on the right corner you can see the depth of several parts in the estuary from 1950 to now, and then you can see that in some parts it is even 7 to 8 meters deeper now than what it was about 50 years ago. So the deepening is, next to the embankments, a very important impact on the estuary. So we had on the one hand the long-term changes in the geomorphology of the area, but of course you will not be surprised that another human impact is the degradation of the water quality. And related to the water quality, then of course we had an impact on the ecosystem and the ecosystem functioning, of course. Then in this graph we see the impact of pollution. On the y-axis, we have the distance along the estuary. On the left, Ghent, on the right, or in the middle, the Dutch-Belgian border, and on the right, the North Sea. And it is not the distance that is indicated, but the chlorinity, as we have from the fresh going to the marine part. And on the y-axis, we see the concentration of oxygen. And then you see that in the period 70-75, in the freshwater part from Ghent to the Dutch-Belgian border, in fact, the oxygen concentrations were extremely low, and in fact, it was anoxic at that moment. And you have, it's quite clear, if you have an anoxic situation, that then the whole ecosystem collapsed, and you have, of course, a lot of bacteria and viruses which are able to live in these anaerobic conditions, but all the higher life of invertebrates and certainly fish or whatever is impossible to live there. So that had very strong impacts on quality. And you see that this has very large consequences, because in a very long period of time the fishing was extremely important along the estuary, because estuarine areas are very productive. And what do we see is that over the time there were a lot of small harbors in the whole of the delta area, and all the stars are in fact places where there were harbors, and the fish and also the mussels and shrimp caught by these fishes were brought to Antwerp, where we had already since the Middle Ages a very large and important city. Of course, these fisheries collapsed because of the water quality, but it was not only the water quality that was the reason for the collapse of the fisheries, because if you look, several of these stars, especially the one on the left, is still now very far from the estuary, and in fact this is the result of the embankments, because Paulina, which is Philippine, which is the star on the left, was one of the little harbors along the estuary, and above the star you still see some blue line, which is now a very huge creek, which was an old sea arm. So Philippine was along a sea arm or along a creek of the estuary, but due to the embankments it is not a harbor anymore. So on the one hand, several of these harbors were gone because they were, due to the embankments, not connected to the river anymore, and on the other hand we had, of course, the collapse due to the water quality. And on this painting from the Middle Ages, you can see what a huge diversity of fish species that were present in the estuary, because this is just a picture, a painting of the fish market in Antwerp in the 17th century. And all of the fish that you can see here are caught by these fishermen along the estuary. And you can even see under the table that there is a seal, there is crabs, there is sturgeon, there is eel, there are whatever, mussels, whatever you can think of, oysters and so on, which were present. And now This is the detail of the harbor of Philippine, which was the major mussel harbor, and there you can see that it is not connected any further with the estuary because of the embankments. So for a long time, in fact, because of all the embankments and then the deterioration of the water quality, the main reason for the estuary was the access to the port of Antwerp. And the combination of this economic importance and the huge pollution and the collapse of the ecosystem give the impression that it was just a fairway to the harbor and it was no ecosystem anymore, and the ecosystem was certainly not valued because the only importance of the estuary was the economic one, the entrance to the port and the development of the port of Antwerp. But of course, still an estuary is an extremely important ecosystem, and starting in the middle of last century, initiatives emerged for the protection of the important values, because at that time it became clear that the deterioration of the environment was becoming a very important issue. So worldwide, there was the development of the initiatives for nature conservation, which in fact started already at the end of the 19th, beginning of the 20th centuries, with also the first big national parks in the United States. But halfway the 20th century, also in Belgium and in other parts of Europe, the importance of nature became obvious, and initiatives started to protect these. And we see along the Scheldt estuary that the first nature reserves were established already around 1970, where we had what is called the Durmemonding, the Mount of the Durme. We had a small marsh Kijkverdriet in 78, and then also in 76, the huge marsh, the Droomtland of Saftingen, was protected by national laws. The objectives in the beginning was, in fact, very much, first of all, species-oriented. And here we see some very typical species from the freshwater part of the estuary, the marsh marigold and the blue trout, which is a typical reed-breeding bird. And so the objectives were to protect these species by maintaining the habitats in which these species are occurring. And that, of course, had as a consequence that the habitats were managed for these species. And here we see that the mature marsh, which is typically consisting out of willows, that there the willows are cut to get reed beds, and the reed beds on the left, they are also cut in winter to allow the marsh marigold to flower very much and to expand in spring. So the management is oriented towards these species in this case, and the habitat is managed to allow these species to expand. But this has a lot of problems, because the development of these marshes and the vegetation in the marsh is depending on the local conditions. And the flood frequency is very important. And what do you see here is the probability of a type of vegetation to occur in function of the inundation frequency. And we see if the inundation frequency is 1, this means that the area is flooded by each tide, and you have two high waters per day, that then you have pioneer vegetation and followed by reed vegetations. And as soon as the inundation frequency is reduced, so when the sedimentation is accreting, that you have less floodings, then you will see that you will have mainly willows. And what is happening now, to get these reed beds and the marsh marigolds which are growing in that, you need an inundation frequency of about 0.7, which means 70% of the tides the area is flooded. But your area has a condition with more or less 30% of the time which is flooded. So in fact, it is not in the good position to have this reed. And under normal conditions, you would have the willows growing there. But the maintenance, in fact, you are reducing the willows to get the reed, but the reed there is then occurring in a situation which is not in equilibrium, because under normal conditions you would have willows, which means that you will have to continue the management forever and ever, because you are maintaining a vegetation which is not in accordance to the abiotic conditions. That's one thing. And the other thing is that, of course, we have these geomorphological changes, and we have a lot of erosion because you have higher current speeds due to the deepening of the area. And very much these problems of erosions were tackled by bringing in hard structures, like the use of riprap, which is just stones that are put on the eroding edge of the marsh, what you can see to the left. But even then you see that there is a further retreat of the reed bed, and so these hard measures in fact do not help to maintain